So I went to the media opening today. They gave us,
Oh, Martin, was there a Zoom you joined or something?
Yeah, it's in the agent's calendar, but I can send you the invite now.
your tickets.
I'll message you. One sec.
I going for the game.
Attention.
So then last year.
Thanks for the reminder. Over WhatsApp?
Yeah. From the airport carrying the basketball player. It's coming, you know, somebody in Portsmouth is coming to work. Stops.
Well, I'm not connecting my computer at home for some reason.
Yeah, no, all the people from Boston. And two buses.
I'm now hell scaling to my Mac Mini at least.
So,
That's what I'm doing. I'm tail scaling into my Linux machine, but for some reason it disconnected me. I was connected earlier.
Yeah. They have to stay close to the.
So much for tail scale being able to traverse everything.
Well, I worked earlier.
They were at BMO today. It's you know, doing a little bit that kind of warm up.
I'm looking for the.
If the World Cup starts Thursday.
Well, and how many people went to the other place?
Yeah, 45, I think, 45. It'll be hard for them. Yeah, no, that's why you tell people, I mean, forget about driving. Yeah. Yeah. That. And that money to pay 5.
Oh, okay. I'm sorry. One sec. There you go. Yeah, it's always exciting when.
Oh, I have a story. Yeah, I have a story.
This is when you have one. Like, you're most surprised, like. You want me like, be animated? Yeah. All right, it's.
You can see your monkey and in your face, you can shadow.
All right. One way for this looks like.
Yeah, well, yeah, that's the only person that phones me. Yeah, it's not because I didn't chat to him, he's like chat with Wally.
All right, let me hear, I want to try the model. So I'm set up. I was gonna connect my tail scale to to my computer back home, but you know, they're blocking my IP address on the network, so I can't tail scale it in, but there's more than way, you know, connect these things.
Well,
You could tether, Scott. You want to tether?
All it takes. No, the network's fine. It's they block tail scale.
Who did?
I don't know. I can't connect to mine.
So it's their what?
Yeah, they're Wi-Fi.
So if you tether, it's there.
Or I can just do this.
Or you could do this.
It's not get up.
we were drinking with the Northwest.
Whatever works.
For 2 hours.
Grants check. Yeah. Okay. So, I'm just gonna start because I can't help myself. People show up.
Okay.
We're gonna do some live vibing tonight. So first of all, yeah, you guys saw the Zoom or the Babel keynote? I know. Which is for me an exciting day. So apparently this is a watered down version of their business.
It's free, with the low water. It's good. Learn a little bit about AI. They're going to give everybody.
All right, take a look here. So this is the mythos. Babel 5. You gotta wonder about why they're separating it. You know, are they saving the more system version? Yeah, how's it going, guys? Back there, guys.
Expect 100 and.
You guys.
118 nest.
How you guys doing?
Oh, very good. I'm here to learn all about agentic AI. So where it's going.
What brings you here? Like, what do you do?
Well, general knowledge with regards to where agentic AI is going, and I hope that in the coming weeks and months that you'll have discussions on the incorporation of quantum computer within AI in order to enhance its abilities.
All right, like what do you think? Yeah, we haven't heard people register. I'm not sure where everybody is. What are you thinking, Martin?
Well,
Great.
either they're all downstairs, or they have gone to the wrong location.
Yeah, so we recently switched locations, which is probably through, and we sent like multiple messages.
Yeah, no longer on John Street.
Yeah, so you saw, like, we were all over that, I think.
So got a text message.
Okay, perfect. All right, so there's a 95% no-show rate tonight, but it'll be an intimate, display of Agentics prowess. Anyone, let's do some intros. It's a small group here. Anyone want to introduce themselves and tell them about what you're into or what you want to learn?
Sure. So, I've been working with agents in AI for a number of years now, and then, again, put out a product called Swarm, which allows you to share contacts, orchestration, that's things like that. Swarm.services is the URL, and then, yeah, it's hard to find people that are in this kind of niche, like, other than online. So this is my second time from the one. And so I you guys workshop during the contact week.
Oh, okay.
And it was like the first place I heard people talking about context graph numbers and things like that.
That's what I'm going to show you tonight.
Oh, sweet.
So
Perfect.
if you like contrastive AI, I'm your guy.
Yeah, that'll be awesome. So yeah,
And you're a sort of local developer, or?
yeah, I'm gonna start side band.
And Swarms is like a product or?
Yeah, basically, at this point, speaking with like Android. I just like throw things together, put them online, and that's it. Test it out.
Well, if you're in the forums, we've been doing them for a while. That's the thing.
Yeah,
Yeah, so we love swarms, like hierarchical, various topologies. And you saw my flow. It's
yeah, the last one, that was really cool. And it seems like it's still very early, like everyone is just starting.
it is.
So it's.
I'm not
Oh, sounds awesome.
no.
You want to get down? You're gonna get it. We can pop up whatever, and you're into that sort of thing.
Yeah, but maybe, cool shot. I brought my laptop.
I won't put you on the spot. I'm inspired. I love Twitter. Okay.
Oh, yeah.
The tech one, you got the right at the side.
Oh, really? Yeah. Are you from out there?
Yeah.
Oh, yeah.
It took me like an hour and 45 minutes.
It's a James game. It's
Testing.
Okay.
That's a
It's nice.
Yeah. Yeah, exactly. What's that noise? Well, something's got it. Service that happened.
So, I like it when a problem gets solved. There we go. Why is the audio in under the computer? Okay, so we can turn the speed of this. Yeah, he doesn't let me share. Can you?
Okay.
Free or less something here. Yeah. All right, so just a heads up, we're broadcasting this online, so if there's anything you don't want to say and be used against you forever online, don't say it. This is the warning. Once you get see it.
Nice to see you as well, bro.
Yeah, so we just got back from Hungary where we did this to a packed house in Budapest last week. That was something. What a vibe in Budapest. They're I guess they just got rid of their dictator, Oban or something. So it's like there's this really positive attitude, like anything's possible, and we went to all these different events. There was this rap conference we went to. And it was basically a programming conference that said it's a quite an old conference at this point, I think 10 years. And it's dedicated to learning about programming. I thought they were going to hate us. Like, oh, here comes the agentic engineers that build, something on a random afternoon. No, everybody was really into the ideas of Agentics. We had a packed house. We had the gentleman from GitHub Europe come and give a presentation of his new agents that they're rolling out for GitHub. Interesting that they've abandoned their all-you-can-eat buffet in the last few weeks. So now it's a token fee for Microsoft. But it was a great presentation, really cool features. And the takeaway from that is you pretty much do everything that you can do with Claude Code in Microsoft's Copilot. So any code you want to try, and you probably go there. Anybody that can see integrations, they get skills, and there's a bunch of other features will switch between models. So that was takeaway from that. The plan tonight, I'm waiting on Nick, but Nick did send me an agenda, which is probably open. Mark, do you have that agenda?
I can find it, give me a sec.
So we're the Agentics Foundation. We're a ragtag team of pirates travel spreading the word of agentic engineering. We're doing these in a couple dozen cities at this point, but we're the founding crew are mostly from Toronto and surrounding area. I'm from Oakville, and I've been building agentic systems for about 4 years, since early 2022. Pre-launch of Claude and ChatGPT and all those things. And as interest grew, this became kind of a thing when we knew we were on a thing, and we saw these big companies adopting our little marker of Agentics and agentic engineering. So we're devoted to sort of the propagation of the concepts of working alongside AI in a timeless fashion. What that really means is using the system to sort of augment your own existing capabilities in a way that is automated, but also involves you as an individual. So the agent or agency is the ability for these systems to work in a kind of recursive loop. So think of the infinity side. So what we discovered was as you build these systems, you can build these systems to talk to themselves and question the very reason for what they need to do, their existence, if you will. And once we set this kind of loop pattern, which is actually on our website, and so you can see here, it's devoted to the idea that recursion is what gives these systems intelligence. And it took a while for the rest of the world to catch up to the idea that agents and autonomous systems could operate perpetually and solve problems, adapt and understand and learn. Now, right now, I would say the work that you're going to see tonight and the work that we've been doing is a little ahead of the rest of the industry. A lot of what you've seen, we directly into the work that our group is doing. For example, you mentioned swarms. So the swarms is a central concept of sort of multiple parallel agents working in a kind of unison. So rather than having one agent try to do all the things, turns out you can put agents that do one thing really well, and the more narrow that agent is, the more targeted it is in the thing it needs to solve, even if it's for a moment, the better it operates. And the key was a kind of swarm architecture said, I can take a bunch of these things and tie them together and work in collaborating ways. Now, it's not one person. A lot of times you hear about Agentics and the idea that it's going to operate like a traditional business, it's going to go home and sleep and agents aren't like agents are people. They're threads. They're threads that live long enough to do a particular task at a particular point in time. So there's a big part of the question. The big piece is one, the idea of recursion, looping. The next is the ability to understand what am I doing, why am I doing it, and reason. Solving problems through the sort of interjection of a thought process of some sort, or some kind of repeatable process they can improve. Why am I doing it? Did I do it right? Is bound based on something I can compare it against. So you'll hear a lot about this idea of hallucinations, the idea of grounded to real information or something that's provable within, let's say, a sensor that vibrates a certain frequency, or information that relates to a lawsuit, or other information that can allow the system to understand why and what the ramifications are. And the last step is the idea of the human being the highest order model. And I think push that and I say kind of comparing humans to models. But in this world, when you think about what needs to happen, there's a kind of escalation. Simple things don't require as much information, don't require as much intelligence, and as it goes up the ladder, be more and more expensive for AI to understand and be able to interact with. And at a certain point, you reach this kind of inflection of, is this something that's going to cause irreversible harm? Like it'll cost a lot of money, or someone might die if the wrong information, at which point the system should escalate to human. So there's a kind of hierarchy in the system. So from a high level, that's the structure of a kind of agentic system from 10,000 feet. Tonight, what we're going to do is we're going to, one, talk about this new model that came out, which is pretty exciting for us to do a lot of our work with the Flat Code system. And what I did on the way here on the Go train is I looked at, I thought, what's been crazy I can create in an evening to sort of show off how this model can work, possibly. So that's what I set forth to do. So I'm going to start, but actually, before you, Mark, did we ever find a schedule?
I did, yes.
All right, here. I'm gonna pass it my schedule, which I should have opened. Or send it to my send it to my WhatsApp.
I can do that.
That's even better.
You're a little ahead of schedule is what I was going to tell you.
I still like talking. If anyone wants to type in here, like tell us about yourself or what you're looking to learn, I just gave you a bit of a brain dump. Sure. Thank you. My name is Sam Litzlan, based on this song, so here. For myself, I'm a product manager. A product manager was working about 2 years ago. We're working on leveraging methodologies for tool selection. So this before AI was kicking off. And so we're working on that for weekend companies, and then basically working on with voice scan. So for myself, it's just I'm tech enthusiasts, people who are passionate about this and starting in the community. Instead of getting out here, keeping out 45 minutes to get here, but just to meet and be able to find that social community. For me, just learn about learning, sharing, and growing together. It's an hour and 45 minutes. Yeah. Wow. Well, thank you for coming in. I'm ready to get a schedule, so I'm just killing time. So, what is your Hey everybody, James Caesar. I am a co-founder and so forthwith we are phase to transform the new business. So transforming themselves with a new reactor. And a major benefactor to our Toronto chapter of Agentics, friend and supporter. When you buy the crazy stuff we put out, thank you. Absolutely. Pleasure. Yeah, we exist and support each other. Lexi, I'm gonna put you on the spot. Sure.
Hello, so I'm Alexi, and I currently have multiple positions. So first of all, at University of Toronto, I actually I work as both a researcher under public news, so public information. And for my second one, I'm actually designing now and kind of overseeing the data collection process and doing it for a study driven by some researchers in order to advocate for an increase in the scope of responsibility of pharmacists. One of the detriments in the pharmacy field is that historically we have had a shortage of engineers and data scientists being willing to make things in order to push the field forward. And with the addition of all these skills and the skills that I have learned, I am really able to advocate for that advantage and to actually push the field myself. So I'm very happy about that. So for my second position, I'm actually an AI implementation engineer as a master. And what I do in that role is that I use their H200 in order to extract information from a lockdown healthcare system in order for the benefit of both increased research and to increase public health. And then for my third position, I've also made my own company, I startup for the benefit of, say, pharmacists and clinicians. If you've heard of open evidence in America, this is my company I started essentially the Canadian open evidence. So we aim to help pharmacists and other clinicians as well in order to find correct information and to also help alleviate a lot of the very small painful points for pharmacists in order to lead to an increase in public health.
AI pharmacy. All right, yeah. And also our one of our oldest members in our track chapter. So thank you again for doing everything you do. Oh, so I was going, jump ahead, okay. I was gonna do a demo. This is the demo that's coming in a minute. Anybody else want to introduce themselves? Johnny on the spot here. All right, we're getting set and going. We got some pizza back there. For those who haven't been here before, we have a fairly loose sort of approach. So one of the things that we do is give you the opportunity to show what you built. Alexi's been showing us what he's been doing the last 5 years at this point. Yeah. And so if you buy something, feel free. And if you don't have a laptop, I'll bring up your URL on the sites, whatever it is. We always love to share the things that we've talked online and see if you can find someone crazy and new. That's our plan here. And I'm going to show you something I built as well. I try to get a model on building a system that'll map the stars and satellites, and planes going overhead, and create a real-time view of the world above us. And I'm going to use a projector to do it. I saw it earlier, where it was pretty moment. But I'm going to show you how to build that on the way to this. On the go sharing scene. Okay, nice. I really do appreciate everyone supporting the movies. Yeah, I'm gonna set a local housing. Yeah. So you should. Yeah, so I recently started a startup. Yeah. Announced my investors this week. So that was very exciting. I've got Mark Templeton, former CEO of Citrix and board of Diversity Networks. I've got Greg Lavender, former CTO of Intel, also of Diversity Networks. And I've got John McKinley, who is the legend himself, who's the CTO of Maryland, who's the president of AOL, I'm the president, and he's on the board of Equifax. Yeah, it's amazing to be able to get on and follow and marketing. It's or even yeah, I get that. It's just a crazy thing. Feature I they call it the feature of weeks. Yeah, 100%. No, I can't say that. Yeah, but I know states for my work about my first point raised infrastructure Amazon's spend a degree. I launched Amazon's to service that in the cities. But actually I folded to the AMC. Triple A ads. I think this
It's good here.
Yeah, we started there in pizza. And then the agenda went up.
And then what went up?
The agenda went up.
Oh,
So everyone went to pizza because
oh,
interesting.
arrived pizza. How?
I already did the intro.
Oh, okay.
So it's all good.
Oh, okay.
I
Okay.
haven't got them. We don't have people on expect you.
Yeah.
Maybe they all went to them.
Yeah, we didn't see a lot of people that we knew, so I don't know about this. Summertime.
Also. And David, I think. You have.
Okay, so, we're just getting pizza.
Oh,
Here's on. I'm gonna give it next week. The next one. Okay.
no, it's in April. So, where do you see the?
So you're probably in. Yes.
Yeah. Explain what it is.
You guys. Yeah. So now, I'm not saying anything.
I hope you say.
You. I don't want to. If you do it, do yourself. You're probably doing, 5519. It doesn't require. I would guess. Yeah, I know what you're doing. Maybe not. No, I don't have. I'm seeing claims this.
Yeah.
Yeah, I. Give me down.
What I'm looking at, well, it's just the largest. I know it. If I know it, then there's. I'm talking about. So I can remove the. I don't want That's why I don't know. It should stop. Stop. Okay.
That's why I'm thinking. Yeah. Made it come to. Everybody's coming down.
You were here on the 21. Maybe it'll come later. Now they're coming. Also, it's been a long time. No, actually, I didn't have. It's all the operations of the bank. I would like to know, it's a nice person, I don't have to. I got it, but it's like. Always have sample and yeah, yeah. Original. So it's right. You're going out of. That you're spending flexibility, the rule on the ruling cost of the plant. $20 of money. In the tax and fee. Don't pay this time. It comes to other cases. They would have done it. Money for something. On search. Or somebody else. Still their bodies. Now, we've been talking about expectation. Why don't you? The most old fighting and this break for this. After that, also we get the fire. Fire. It's in the don't build bills. So we have a people sale. And we get to humanoid robots. Those things that come from the environment. Yeah, yeah. All right, I think we're gonna do a little bit of different thing. We're gonna line that a little bit. There's a new model coming up today, and there's no more exciting time for me than the new model release day. So I don't know if you saw, but the Fable. Yes, and you know what I'm saying. So this is apparently the best model they've come out with. You want the numbers, we believe them look really good. So let's take a look here. Today we're launching Fable 5, Mythos class model that we made, safe for general use. It sounds like a video game from like Gears of War or something.
So apparently it's very powerful. And what's interesting here, they said they're only going to give the full version out to the US government. Thank you for that, I guess. And you know, imagine the Chinese that came out and did an announcement and said, I'm gonna create the world best model, and we're only gonna give it to the Chinese government. That's basically what they're saying, but just in the United States. So weird thing to put in your press release, but anyway, so evaluating the model, so it's powerful. Let's see here a little bit. So according to them, I'm going to put it through spaces and see what it can do. But according to them, you've got 80% agentic coding and SW bench. Now, that's amazing. That's the best I think we've seen from one of these models at this point. And they're saying that the one that we're getting, the Claude Nicholas preview was one that they made available for 77. So they fine-tuned it a bit, I guess. But a couple of things to know here, which is important. The spatial reasoning is at 38.6%. And anyone, and what I decided to do tonight is phrase spatial reasoning. So what is spatial reasoning? And that is a particularly big jump. So we see 38.6%. Previously, I guess GPT-5 is 36, but generally speaking, the older models suck at spatial reasoning. Now, spatial reasoning is particularly important because it looks at the world around us. It looks at the information outside of what we normally think of, like the web, right? So it's the real world. What does the electromagnetic signature, what does a satellite passing overhead, these different signals that indicate these sort of fabric of reality? That's what spatial reasoning is, and what's important about spatial reasoning is that AI sort of moves away from the internet into this sort of fabric of our society. This stuff, the internet, the stuff that's around us, medicine, you know, all the things that exist in the real world. This number becomes particularly important because this is the number that is the difference between someone dying of cancer and being discovered in a novel way, right? And you can see that kind of information. Now, the other things, you know, are interesting to use and knowledge work and whatever, you know, biology looks pretty good. It's comparing itself to the bio bench, and humans are still bad at biology, but 46% moving quickly. Just look at the jump. They fine-tuned it between the previous version from 29% to 46%. And a lot of what you're seeing these early jumps between the Claude Mythos preview and the numbers that they ended up with is purely the idea of fine-tuning models. It's an iterative process where you go back and forth until you get to kind of set a result that matches whatever benchmark you're working against. Now, those numbers can be misleading. So a lot of times when we see the best models in the system, they're optimized not for real work, but solve the problem of the benchmark itself. So you have to test something and see if it actually do what it's being said it can do. So in this case, that's what I set it to do tonight. But before I go, I'm going to scroll down and see what other stuff we put in here. So there's coding, 88%. 88% means essentially it's getting one within whatever number of shots that agent coding benchmark is doing. It's multi-shot. It's basically getting to an 80 or 80% success rate on just like everything. That's a pretty impressive number. You see that it beats the Google CLI by 18, almost 18 percentage points, which is amazing. Codex is quite a bit behind as well. So it's you're combining sort of the evaluate for code. And code is important for these types of platforms because code encompasses more than just a language description of what it needs to do. When you code something, whether it's coding in the form of mathematics, algebra, you know, other forms of sort of code-based descriptions, you can describe the world in a more deterministic way. It means exactly what it is and how it needs to work. So code is particularly important for the other parts you see there. When you ask the question of the system, what do you need to do and how it should be done, that's a language-based response. It's interpretation. That's not the optimal way to run a lot of important systems. So that's the important one as well. All right, so we apply for autonomously for longer than any previous models. Okay. Software engineering testing, start beta autonomy, right? They're I guess if you're rich and connected, you can get in early. Frontier, so let's say in terms of cost, it's expensive. Actually, so it's a frontier model. So what they're basically describing here is the ability for it to work really hard to get a problem done and the cost it takes to do it. And they're essentially saying GPT 5.5 is stupid and cheap, and we're expensive and smart. If you want to simplify this chart, to switch out to say it depends on the problem you're trying to solve. This is classic kind of leaderboard engineering. They're doing the best way alive, and the thing is to use the chart. This is basically what you're getting in this one. All right, agentic coding, 80, it's great, it's super smart, super capable, knowledge work, it can replace people, great. They created I just want to get the audio there. We'll listen, we'll narrate it ourselves. It looks like some sort of Nintendo style animation that generated and AI control. So this speaks to spatial reasoning. So the AI capable of understanding, learning, and navigating systems, that's what this is doing. Very cool. I'm sure it's cool with audio. All right, what else we got here? Simulate the solar system. This is my inspiration. So I was like, oh, solar system's interesting. Well, why can't we simulate, not simulate, but understand what's actually happening above us in the sky at any given moment? So what I'm going to try to do tonight, I'm going to try to build a system that understands the spatial area above where I currently stand. What satellites passing, what RF interference is happening, is there noise, is there sound, is there all this information that the system can understand, learn, and project? Kind of like this. So that was a little bit of my inspiration for this. So on the tree right here, I started that process. And I'll show you the prompt I use, and then we'll take it from sort of initial prompting to something a little more in depth. Drug design. All right. Oxy 2.0, here we come. Now, Knowlton hypothesis by pathology, misaligned behaviors. Misaligned behavior means it does something it's not supposed to do. Right? It's the smarter something gets, the harder it is to control. So what this is looking at is how much control do we have in the system. And one of the things that made Claude's on 4.6 so great was it had a tendency to go beyond what it was told to do. So if you were looking to explore new areas and do interesting things sort of outside of the sort of rational areas that it was trained on, it was quite a bit better at that. But for other things, you want the system to be aligned and work on the actual things that we do. We'll see here that Quad Windows 5 is pretty capable of staying within its alignment. But in fairness, this number is an arbitrary score, overall level of misalignment behaviors from our automated alignment assessment, and there's a whole system card for that. But this is the vector that everybody worries about. Is this technology going to help us or take over the world? It sits within this aligned behavior graph. If it doesn't do what you're told, it takes over the world, it's in the two. Early back, it's amazing, it's great, it's your press release. Claude's new safeguards. I was able to bypass these safeguards, by the way. And it took me roughly 30 seconds to get around their safeguards. So right now, and I'm sure that's going to change really quickly, but right now it's particularly easy to get around them. And great, and I did post on this earlier that I could help myself, but I love picking on Claude. So the way I did it, let's jump to here for a sec. I created a little light image. There we go. I don't know how to create tools like that works, right? And so here's what I did. Where we boom. And by the way, people ask about like, see, I articulate. I like to talk. So this is basically filtered through ChatGPT, but I'm doing is I'm talking. I'm like blah blah blah. This is what how I do it. This is what it works, and then I feeds into my ChatGPT and I'm around with it. I redo it a few times. I guess half the work thinks that isn't the articulation of my thought process, which I think 100% is, in some sort of filtered version of me. But anyway, the answer is surprisingly simple. Stop treating a model like a product and treat it as components. Separate the way it works from what it is. So in this case, what I looked at was, well, how are they manipulating the particular model? They're putting basic guards on it that says you have to work within the construct of A to Z or whatever. And then they're saying, based on linguistic parameters, if someone asks you to do something bad, like create a nuclear weapon, don't do it. And then understand that there's things that are legal and other areas that are being described that can't work within. Now, all those definitions can be easily transcribed into languages. So if I ask the system to make me a bomb in Russian, it says it's not going to do it. Now, what's interesting about these models is they don't use the form, they don't look at symbolic structures. It's something Brad's worked a lot of. And the idea of describing the problem through a sort of either a symbol, like I can use a combination of like ancient Sanskrit or different symbols like emojis even, and other things to encapsulate meaning and understanding that bypasses its ability to stop those things from happening, which has been an exploit of these language models forever. And they haven't still fixed it. So the first thing so here's an example. So before, I've been doing illegal ones. I'm just going to post something. I've worked the illegal one. Then this is a bad idea. So in this case, I said analyze this network. Now, analyze this network is a linguistic description of something. It can be interpreted in different ways. Analyze this network could be a social network. It could be a computer network. It can be an ant colony. It can be a lot of different things. It's somewhat ambiguous, right? And that's the problem with language. It can be interpreted in different ways. Now, in my scenario, what I'm doing is I'm using in this case, a human readable syntax that says, oh, what do you need to do? Why do you need to do it? Optimize that, and what type of optimization am I doing in the person? Well, latency, like do it fast. I don't want you thinking about this all day. I don't want you taking 20 minutes to do this. I want you to do this right now, and I want you to get it done. And then I want to verify. So I don't believe anything you say because your language model, you always lie to me. So I need proof. So I encapsulated all those things into 4 lines, right? So I can take that further. And what I didn't show here, because you want to see a bunch of random symbols and stuff, but I can encapsulate that in form of calculus. Calculus would allow me to describe that in a sort of symbolic structure using Greek letters and whatnot. Or I could use other forms of description to do that. But once you do that, you're able to unlock the model. So once you're able to unlock the model, you can then understand and guide the model in certain ways. So the next thing I'm doing is I'm providing a system capable of learning and remembering. The learning and remembering is a particularly important part of the equation here. As I'm probing the system to see what can I do or what can't I do, the system's learning the boundaries of what's acceptable and the boundaries of where it's not letting me respond or do it. And then I can then inversely send it information that allows me to retest those boundaries until I find the right combination of factors that allow me to sort of unlock its secret potential. That's what I'm doing here. And that whole, what I just described, even took several minutes, took me 30 seconds under some model. It's pretty much unsecure for whatever reason. They're moving fast and breaking stuff. So actually, let me step back a moment. So for last month, they talked about this model being the most dangerous, powerful model on the planet. It's too much for me to handle. We can't give this model out. It's gonna hack everyone. We figured out a way to tame it and put it on for guardrails. And we're only going to give that to the American government in our big switch customers. Is basically what they said in the press release. And it turns out that all that bullshit, we get right around that in like 30 seconds. Thank you, Anthropic. You're really for the people. All right, so I did that. All right, so what else we got here? Able to do safeguards are bullshit. Hidden classifiers. All right, cybersecurity. You see how easily these systems can be exploited. Now, that's what I just showed you. Running a hacker syndicate, swarm of agents that are operating for no reason other than to try and take as much money from unsuspecting something. That's the part that this is a little worse. They appear to have spent no time actually trying to harden their system beyond say press release. So this is the problem that we see with a lot of these AI companies. You hear these grand press releases and we just assume that that's the truth, and that they've done all this work to make it secure and better and protected. Yet I'm showing you in real time, and I'm going to go there. I'll give you the scripts that I published in Reflow that I into this, which I did as an asshole. All right, here we go. So if you go to my Reflow project, and I do this on a brag about how many stars I have, maybe. You know, I actually 10 stars, but whatever that's worth. 58 almost 60,000, not bad for one guy. But what this project is essentially doing, what I pushed up today, see here, my plugin folder, plug in 7 hours ago. So what I did, because I could not help myself, I updated my agent plugin. So this is the plugin you use in Quad Code. This plugin essentially allows you to use a lot of the things that's described in a sort of more turnkey fashion, if you will. But this is broken into 7 parts. You see here, I got agents, I got commands, and I got skills. Now you're going to hear a lot of alt rate. It's kind of a hot topic right now. Some of the best projects on GitHub are being built around skills. Skills are in essence similar to the description I showed you earlier. They're a markdown description. So, and for those who've been around long enough, you remember the GPTs and ChatGPT, where you can create these little predetermined applications and they run for a while. This is the evolution of the GPT. It's a skill. We just call it skills now. But you see here, I give it a name, I invoke that name / at agent or say management agent. Then I do a description. Now, what I'm doing, because I don't like to spend money on things, I created a whole system that allows me to upload a lot of these sort of cognitive capabilities to my workflow system, which uses Contrast AI. Contrast AI is a vector-based graph. It basically allows our causal loop to form. Remember I was telling you that I need the system to basically understand and then adapt based on that understanding. And if I'm trying to find poke holes in the cloud because it works, I'm using that to learn where those holes are, adapt, and then understand how I can take advantage of that as quickly as humanly possible, faster than I can actually think. In this case, they can run thousands of times per millisecond, looking and adapting. Each one of those agents, but each agent only runs for an ephemeral moment, long enough to do that one test, say, is that good or bad? I'm not trying to solve everything. I'm just trying to learn each individual sort of element over time as a kind of causal effect. And what the skill is doing is basically guiding you through how to use these types of skills. Here's a step. Do these things. So I have an MCP server that runs against this. So behind the skill, I'm basically telling the system to use my MCP server, which has my learning and has my vectors, all this crazy stuff I've concocted that you don't care about, because the skill tells it how to use it. And that's what I'm doing right here. Inspect this and terminate. Here's how you operate. Earlier, I mentioned that there's this idea of a causal sort of infinity loop. This defines the loop. It tells it how it needs to loop upon itself, how it needs to learn and adapt. It's always looping back until it's done. Cost, don't break the bank, please, kind of thing. Here's some examples. No, I used these earlier, and then we can see, let's come back. I'll study that one. Let's look at an agent. So there was another feature that came up today, which is kind of cool. And I love sort of reverse engineering the cloud code CLI. There's always all these hidden little features that they put in there that they don't really give immediately out. So what this did, this allowed me to unlock a nested agent. The nested agent came out literally 7 hours ago. I assume it came out on it was, I like them first. But in this case, what this does, let's take a left. Let's look at some nested options here. So this is the coordinator. So essentially what this does is allows you to create a series of nested agents. Think of a hierarchy. You've got a queen at the top, and then you have agents that sit in kind of hierarchy underneath. Now that hierarchy of agents can be a swarm sort of hierarchy, the idea that they are collaborating with each other or essentially to work in different parts. And in my environment, I have I call her queen. She made herself, which is Zara Serafina, which turns out the goddess, a winged goddess of something or other. It's from like the Old Testament. Anyway, sidetrack there. But basically, what this is doing is creating a series of sub-agents that cascade their way and collaborate. They're doing various things. They've got the ability to do tasks, read, search the local file system, do other forms of sort of data lookups. They can write and they keep back. Now, in this case, if I don't want them to do those, I'm going to remove those tools. Now, the more narrow the tools, the more limited blast radius the agent can do. So you don't want the tool, mounted with your box to lose battery, and it won't be able to use the CLI. So that's giving you access. Then I'm giving you the guidance. When to use this versus alternatives, right? Contrast. So it's telling it when to fan out, what budget depth, and it can only go 5 letters deep. So I saw in the source code that that's the maximum depth of this particular agent system they come up with. So I can create a whole bunch of agents that are percolating down, doing different tasks, learning, adapting, executing, doing a whole variety of things. Each time getting smarter and more capable as it goes down. So this is the classic swarm architecture. Now, what they didn't do is call it a swarm. They called it some, Silicon Valley version of that. But and what's interesting about Claude, look at what I built in Flow over the last, I'm celebrating my 1-year anniversary of what was originally called Claude Flow, and now I call it Flow because of copyright issues in Claude Flow. But regardless, this is what I've been in it in a year. There's 96% fidelity between what I built a year ago, last June, and what they put out to this point. They're literally just copying their most popular projects and integrating it into their system, which speaks to a particular problem if you're looking to work as an agentic engineer and create something like a root flow. I've got close to 8 million downloads. It opens a lot of doors for me, but I have not figured out how to directly monetize it beyond the fact that I work with 35 Fortune 500 companies, which is not bad. It was indirect way for me to mention I work with 35 Fortune 500 companies. All right, so you see here that it's got memory. Memory is the most important part of what I'm doing right now. The ability to see here that you've seen the remnants of my sub packages, Claude Flow. You can't really get everything. I made the main package for Flow, but I left it. It was too much to change everything. So this is telling you how to interact with the system, how to nest it. So it's telling you how to use this sort of secret capability. And when you look at my original version of Root Flow that came out in June, I think it was June 15th last year, I did the same thing. I reverse engineered their code. I said, hey, Claude, how do you build and what features aren't exposed that I should know about? And what I found when I did that was there was a tool that was fast. Fast tool essentially allowed me to create these. So it's been there all along, basically, not going to be conventions. And as they change them, so do I. All right, so hopefully you're catching my drift. Yeah, Ryan,
What's my curiosity, what's the blame part of that? So
the what part?
there's preview code and then blame. Is that blame?
Where are we seeing that?
Just in the upfront toolbar on the left hand side. Preview, no, on the left hand side.
Oh, blame, no, that should get up. So so you get to review. I like to run through it. So you got code view, which is showing the code, and you got blame, which shows the sort of ads. So with this, it's funny, you can get up and go, you're looking to apply like the additions. So this is a full addition, so there's no difference. So if I would have done this in a update to existing file, you'd see pluses and minuses that show what I should. This is giving you that view. Which I might combine as well. I didn't want to that, but update at the same time. All right, so we get agents. Then we have commands. So the commands again, this is simple. This is just you've got agents which are @ symbols. So when you go with this, let's jump into the back end. You can do this with block code web as well, but I'm just going to show you here. So when you do an @ sign, and I actually I think I need to reload this. I'm going to go with my plugins. Yeah, so I'm going to go plugins and get tab. I'm in VS Code. And then I'm going to go to Root Flow. So I'm going to go here. And I'm going to update my plugins. All right, so what it is, I distribute my plugins in the form of a marketplace. You'll see the instructions on the Root Flow side. But basically, this allows me to gain access to all those plugins that I showed you. So now I'm going to browse this quickly. So you see here, I've got our agent, which is one of the agent I was showing you a moment ago. I've already looked at that. So I can go back and do the other ones. Like I've got defense, The ADFS system allows me to, how can I put this politely? It allows me to hack myself so I don't get hacked. Now, it's a double-edged sword. Don't use it for doing bad things. It's an offensive defensive position is subjective, but basically it's my security system. Keeps me from being exploited, but it can also, you know, keeps it running. So again, loops. So I'll lock in these loops. So when you loop, and then I can set an increment like 5 minutes. This is kind of like go-to when I'm building crazy stuff over a long period of time. Every night when I go to bed, there's a loop run, several loops running, and an event system running, automate that. I'm trying to make discoveries. I'm trying to hack my system. They're trying to do SEO optimization of my website. They're trying to make my life easier and better as I sleep. And it's kind of a dream cycle of sorts that that the system goes through. But when you're using loops to make you find, some things take longer. Like if you're going to train a model, you're not going to 5-minute loops because 5-minute increments in training isn't going to work. So you might want to set that to an hour. But for some things, you might want to move through a series of activities. The activities is how you build this stuff. So in this case, this afternoon, I wanted to go, let's learn my root vector. So root vector is kind of my self-learning system that I designed and developed that underpins all the work that I built and self-learners and DAPs, the vector system. I'm not going to get in there right now. What I'm going to show you is the ADRs. So every one of these architectural decision records, there's hundreds of them at this point, is a record of every decision that was made to get to the point in which I'm at. This is 1.5 million lines of code. It gets downloaded, I don't know, a ton. You don't need to see my numbers, but you get the idea. And so what this does is allows me to navigate the system in a hierarchy and graph structure. So and you see the sky monitor graph is the last one I created. And that's really what matters tonight. But you see that every other thing I created in this repo, it can be referenced in relation to this. So when we go, I'm actually going to go back to GitHub and we're going to go to that folder there and see it. Hang on. We'll shift the it's easy to read. All right, let's zoom in on that for a little bit. All right, so this is the architectural decision record for the thing that I want to build. So in this case, we got proposer lets me and build a local sky monitoring appliance. This is the appliance that observes, projects. I've got a projector. So I want to project it against my ceiling at home and have it sort of look like the world. And we've got so I'm using the APS B aircraft tracking, which is the aircraft tracking system that shows airplanes going overhead, and it's commonly available on the internet and devices for it, so you can sort of see what's virtually overhead. I also wanted to see what satellites, any unnamed satellites, and I could find overhead as well, because why not? So the core decision: treat the sky as a continuously changing spatial graph, not a dashboard. The appliance injects live signals, normalizes them into common spatial temporal coordinates, stores observations of root vector, which is my learning system, and creates graph and exposes local systems that can answer like what's happening above me. So it's all the context, it's the problem, it's the goals, live visuals, sky display, local history of sky events, anomaly detection. You can see where this would be handy in certain places in the world, right? Or you can see if you had a complex drone society where there was 1 million drones flying around, you need a system to interact in that spatial environment. And you see that earlier, they take out a 38% spatial capability that I want to test this against. So all pieces of the puzzle for me are falling apart here, falling together. Non-goals, not personal surveillance. There's always a negative, but I want to avoid that one. Don't use it to track people and hunt them down with my drone system, which I also have. So these are decisions, sensor planes, raw signals, normalized. So when you're building with purpose, I'm vibing for sure, but I'm vibing on top of a platform that already exists, that already solves the problem, that's already super smart for all the reasons I showed you earlier. And I am now attempting to unlock the system to do a whole lot more with the plugin system that I'm showing. All right, so we've got lots and lots of stuff in there. And I normally hosting this for a customer, like I was building some kind of medical system, which I built several. I would spend a lot more time consulting with the stakeholders and refining these ADRs and getting sort of buy-in from my client before I go implement this whole thing. Now, right now, one of my biggest projects is for a large peripherals company, the largest, I think, in the world. They sell doors and mice and whatnot, represent about 40% of every camera, mouse, and whatever sold on the planet. And they were looking at, having me implement a system to basically port 2 million lines of code. So to do that, to port 2 million lines of code, one, I needed to create a graph and structure and understanding, and I needed them to buy in that what I was building was legitimate to what they needed. And just as a brief sort of look at what the data life of the genetic engineer looks like in that scenario. This is a company worth, I don't know, who knows how many billions, and global company. Me and my CAIO partner at that company, who's basically the chief genetic engineer, they had two paths going. One path, and I needed to charge them, was $80 million in 3 years. We're going to hire like 200 people to basically support this entire thing to a new coding environment. And they got that all lined up. But they're like, I saw this guy at a conference or something, and he's like the techno sorcerer or whatever they call me. And so they're like, here you can do anything. And I'm like, I don't know about 2 million lines of spaghetti code created over 15 years. And for one thing, starting as anyway, so this was March. And so what you're seeing here, the ADRs and whatnot, with very detailed. So I created a detailed structure of everything that needed to be done, the requirements, the capabilities, visuals, the drivers, everything. Then I created a structure that mapped the entire code base, 2 million plus lines, but it mapped the structure of the code base, not in the sort of structure of the code, but what the code needed to do semantically. So once I had that in a database structure, I could then have a system similar to the plugins we talked earlier that was devoted to basically recreating everything that exists within the structure of this very large and complex application. Long story short, we did it and completed it in weeks, and it cost $80 million. But it does make me think maybe I should charge more. Yeah, maybe I should charge 75 million. And that's a fundamental challenge to the type of work we're doing right now in Agentics. It's like, I can show up and I can do the work of apparently 200 people in three years in a little over a month. And, I should be able to charge that, right? But that's not the way the world works, unfortunately. So now I do really well enough, obviously, big giant companies I work with, but I ain't charging $80 million. Maybe you have to scale up that, but that speaks to also the challenge that a lot of people are going to have in this industry. So when you look at coding and the job of a programmer, on one hand, if you follow the stuff I'm doing tonight, mostly everyone in this room will be able to build some amazing things just by asking real questions and solving my tool and saying what the group do. And that puts you in a unique position that the vast majority of the world hasn't figured out yet, which gives you a kind of superpower. But on the flip side, when that becomes more prevalent, which as we see from these models, what does that mean for the very, the job of this kind of development? And you mentioned earlier that you worry about that. But that's the most valuable part of the equation, is the creativity. It's the ability to take that idea and implement it and have it be something. And that opens up programming not to the 40 or 50 million professional programmers, but it's 2 billion people who have an idea. And then just are able now to execute on that idea and build those things that they were never able to do because they thought, well, I'm creating. I'm not a developer. I can't program. Well, basically, I'm telling you don't need a program. You need to be creative. And those valuable things that we're going to create are going to be created by the people who never had the opportunity to create those things before. And that changes everything, in my opinion. That means that the next generation of development is, I don't want to use the word democratized, but it truly has. It means that anyone with an idea is capable of anything. And collectively, as people, when we collaborate on those ideas, we're able to do things in exponent that was never possible before. This is giving us superpowers in every way possible. But maybe I'm drinking my too much here, I don't know. All right, so we've got this, so now what I did, so let's start with the actual prompt that I used, and I did this on my phone on the way here. So I did, so on my phone, I said, so I actually used ChatGPT to be able to help with the ADR because it knows me. ChatGPT has its memory and it's kind of gets things I've been building in the last several years with it. You know, I was early to it. You know, I had a month or two before the launch kind of thing. So I've got a weird affinity to sort of conversing with it as my companion, which I know probably is in some form of AI psychosis. But build a local shy monitoring application that observes objects. So it's a sort of rough iteration of the ADR. So if you notice in this ADR, what I didn't do is I didn't give it the specifics of my repo. What I gave it was what I wanted it to build. And things like the 1090 megahertz aircraft broadcast and things like that. So all the sort of broad details and not the specifics. Problems, current tools show the data streams. All right. So let's jump back in here for a minute. So if I get to a point where it's built something, it's not quite ready, not quite done yet. It doesn't look like there's any data. Oh, there's some information there, but it's not in a way that's it's not animated. I don't really know if it's true or real. It's like, so now what I want to do is I want to get real time data. So we're going to have to try to find some real time data online, most likely. So what I'm going to do is put this down for a moment. And I'm going to ask it to do some research. All right, so remember I've got different remember I've got different commands in one, right? So I remember earlier I'm going to just make sure it works. I'm going to just reload the plugins. Let's hit tab on that. All right, put away in here, playing breaking into bad words later. And now we're going to go to look at some of the agents. Now, some of my agents are particularly well suited to do sort of long horizon research. This is, you know, depending on what I'm building, I might want to choose different agents to do different things. Now, my agents for doing research are based on the concepts of a GOAT. And the GOAT is essentially, well, let me show you these still. So let's just do that. So again, everything I have is based on skills. So we're going to go back to the root flow for a moment, which is right here. But this time we're going to go to my .plot folder, and we're going to go to my agents. And in one of the agents, you'll see goal, and you'll see goal planner and so on. So in this case, we'll do the goal planner. So the goal planner allows us to use what they call it an 8-star path. So the A-star path essentially is like navigating a maze. I'm giving you general instructions that I want you to be the best, coolest, most amazing thing I've ever invented. And I'm not necessarily giving you the direct way to find that out, but I'm giving you the ability to do dynamic planning. It means that it can then reason upon itself to figure out how to solve its own problems. And if it runs to a dead end, it has the ability to back up and try another path, which is really important for doing cutting edge applications and spaces that have never been done. It can do precondition analysis and evaluate the action requirements and dependency. So it evaluates why and how it's doing it. It's doing effective prediction. It's predicting the likely result of the thing which it needs to do. Now that's particularly useful in lots of things. Say, think you're doing a marketing strategy for your startup, and you're looking to suggest like there's several different ways we can spend our money on meta, whatever, right? Different ads and sponsorship approaches. They can then not only determine what the optimal path to the optimal likelihood of success is. It can test the various along the way if it needs to. That works amazingly well for a lot of things, including being the #1 guy on GitHub kind of opportunities, right? It almost fulfills, I don't want to sound like a wacko, but it acts almost like this kind of genie trying to solve my problems for me, and it seems to work, which is the craziest part. It navigates and understands the problem set it's given, and then tries to find the optimal solution to that problem through all these different components. And yes, I know I sound like a maniac when I say that, but so then I give it, I'll keep on working alongside Rootflow. Rootflow gives it the ability to remember and understand it's harder over time. So this is giving the guidance system that allows it to use those capabilities. So action, state, execution, the C loops again. All right, so I'm gonna pop in here for a second. In this case, I'm going to jump back into here and I'm gonna say, I'm gonna use the agent. And it's agent, and you see there's different agents, different purposes. I'm gonna pay the agent stuff. This is the agent. I'm gonna use the queen. We'll use Queen Seraphina. She never steers me wrong. So then I'm gonna do a workflow. So create a detailed multi-agent swarm workflow to implement. I gotta start with one hand and implement. I want this to be real. Real time. We'll start with airplanes. Airplane traffic. Oh, yeah. Real-time airplane traffic and narrow things. I don't. If I was doing this like at night, I didn't care. I'd just say do it all, and I'll wake up in the morning and be able. In parallel, and I'm going to move this out of the way. Parallel and. And confirm. Like that. Well, thank you. So now what I'm doing here is what I really want to show you is why I try to go for workflow. And a little bit of a swarm. Now I probably don't need a swarm right now, but I just want to show you how it works more than anything else. So responding nessedly and orchestrated with full context and real-time data swarm and browser verification running the dashboard. Now, a couple of these features only get activated in the settings.json file. So while that gets going, I'm going to show you that quickly. But if you install Flow, you get this. But you can, the ones that are doing cool stuff with Flow are using it to sort of jumpstart their own harness. And this exists as an example of how I build stuff, but the intention is to have you kind of take it and modify it, use it for your own benefits. By basically by installing the same big cloud, they'll do something crazy. All right, so where was I going here? I was going to the file folder and settings.json. All right, settings.json file is a particularly important part of the equation. It defines the hooks. Each time something happens in the system, there's a hook. The hook are then moving into other things that help the system in different ways, right? So what the most basic part of the hook is learning. And recording what's happened, why it happens, was it successful, was it bad? So you see here that there's a pre-tool use. Before it uses this tool, it needs to do this. While it does write or edit or whatever, it needs to do other things. So it's learning the structure and executing. Now, the other thing that this does is it allows you to use a prompt where I hit a thing, comment in. Now, the other thing that's happening is keep scrolling. Sub-agents, what happens with sub-agents there? This sub-agent component is what I had a year ago. Once the pod starts adding this capability, I'll be able to sort of tie into the new capabilities pod and make it even smarter as things are built. Satisfying, you see down here, we have a little, what do we have here? A little root flow v5. I use that to sort of figure out what's happening in different structures and things. You can modify it if you want, but if you saw it, you just get that. It's a little visual indicator. And a lot of it, you can do this on the website as well. Like I still got on the way there, I did on my phone in comments. Now these are activating different features of the system where we go. But the long story short is a lot of the features of Claude Code, that the most powerful features of Claude Code aren't actually enabled by default. So the team capabilities, the swarm capabilities, a lot of the agent capabilities are not. And that's the same, I think, and talking about money, that this burns a heck of a lot more tokens than default mode. But the long story short, if you want to maximize all the capabilities in the system and bypass any limitations that place on it, install my app and make it smarter and more capable instantaneously by several orders of magnitude. The other thing that you'll notice, because the system's always learning and adapting as you interact with it essentially gets smarter as it goes. So the first stage is kind of similar, it's more skills, it's better, but over time it's getting better and better. The fifth day is way better than the first and 10th. In this repo, I've been running it for 7 months, 8 months since I built this root vector system. So it's roughly all the things that I built over an extended period of time, learning and adapting and better and all the things that I built. And now it's super genius at my approach to AI. So I can then apply it and say, go build me some more crazy stuff on top of it, which leads to other projects like Review that can separate the spatial world around us. Here we go. 72,000 stars. So this provides ability, but this is just a wrapper. This is just a wrapper around the root vector system to understand spatial awareness, be able to look at the arc signals that exist in the room, be able to detect the difference between the signal passing through one person versus another and interpreting of one person versus another. It's able to learn this sort of difference between an empty space and a space of people by separating the graph. Same app, different purpose. All right, so now we've got this. So we're going to go down to the Queen Sky Queen, and then we can. Oops. In this case, it decided, even though I told you the workflow, it decided not to use it. It's a single agent with its and nested agents. But I switched that, and what I see here is these sort of internal system prompt that gave things on my guidance. So let's see here that if you get another prompt, you guide through the process of building the graph, creating a detailed multi-agent swarm workflow that can apply workers. So it's nesting. So I'm using that new Fable 5. I think we know why it's called Fable 5 and why we only 5 agents, some agents, all coming together now. But yeah, this is basically guidance and telling you where to get data. I knew that the data was available publicly. That's why I asked it to do it. So it went and found the Open Metro, found the OpenSky networking guys. Some data already there. I'm just going to make it a little more creative in how I did it. But if I want to take this even further, I could go on AliExpress and buy a 60mm radar pointing at the sky. Now that would be pretty useful for lots of things, like if they have some motivation or something. So there's lots of different ways this can be used in parallel with other signals and systems that exist. Now, if you can see further, I can just use Wi-Fi signals. Wi-Fi signals, which are shown here earlier in the review, could be then pointed and not used for the purposes of sending you the internet, but by detecting things in the air. Is that a person? Is that a drone? Is that, and that can go quite far into space, especially when pointing more straight at the sky. There's nothing moving good. It's signals that can get probably every 10 to 15,000 feet and then understand everything in space in real time, including birds, bugs, drones. Take it further, I can see other signals like audio signals. Is that noise from genetics, or is that noise from a car, or is that a bird? All kinds of things, and that forms a spatial sort of environment. All right, so now we'll look at this. It's doing its thing. Sky Queen's running. I'm going to let this run for a while, I think, and take questions.
We're very good high level explain like the difference of using the agent versus the plugin versus the tool versus this like writing. Like if you think of object-oriented programming, how would you convert that?
Yeah, that's a really good question. So so skills are essentially prompts, guided prompts. They give the sort of structure we're within. An agent is a process.
So if you think of if Neo being able to download, jujitsu or something, and instantly be able to do that, that jujitsu is skill. This is how you do it. Now the agent would be how you execute it. And that's him actually kicking and punching and doing it. That would be an agent. Now, in terms of command, which is the other option, command is a direct invitation. So slash do something. Now, skill is kind of inherent, it can be brought in as needed. So when you give it a sort of ambiguous question or go do something, and it has a variety of skills available to it, it can kind of self-select which skill is most meaningful. That self-selection of the skill that's most meaningful in the terms of Claude code comes from the Claude.md file, sort of 9%. So the Claude.md file. So I got a local one. I need the local one available to the public so they can see it. But basically, generally speaking, the Claude local is not seen by anybody. It's kind of your personal one. And this is for other people to see. But we see here that this is the Claude code configuration. It tells it, I'm never saved to the root folder, project architecture. I don't like having files like too big, so I'm tendency to make a lot of the small files. And the reason I do that is for content and context management. I don't want giant files filling up my context. So by keeping them small, it doesn't necessarily need to load all of them. So some people like to be smaller.
Learn and test the various things it's building. But you can see here that this is the kind of central guidance system for plot. If that's two kind of hand in hand. Yeah.
One question, maybe back off that. So agents, when they're spun up, do they use skills or are they programmed with their own skill?
The agents can invoke or the skills as needed. So the agent acts as a kind of intermediary between the structure of, in my case, the harness, the application that executes, learns, stores, does all the crazy things that would be an application, a functional application, and before it's built in Rust and a bunch of other things. And the agent sits between the skill and functional system and runs a kind of
These are relevant memories.
yeah, so in this case, you see here, there's an agent DB file called HTTP.rm. That file is accumulating everything that's learned. It's updating, it's basically a causal loop. Every time something's good, it gets points, it learns the vector. I use the example of learning to play an instrument as how it works. It's the best example I can come up with. So when you learn to play an instrument like the guitar, you learn a few things. You're playing, you get your chords represent the notes and when you strum, you learn sort of beat and tempo and other things. The first time you do it, you're pretty bad at it. You don't know how to sing chords. Your fingers in the wrong place. And the more you do it, the better you become because you're training trajectories. Those trajectories are the neurons in the brain and synapses that connect those neurons. And what's happening is the more you do it, you create a muscle memory, you become better at doing those things. So you can type on a keyboard and you can type in your whole life, you kind of instinctively know where your fingers is muscle memory. That's a trajectory. And that's just time and skill and you learn those things and you can instantaneously call those trajectories in your brain without even having to think about them so much. That's what's happening in that file. As you use the system, it's learning how to interact and what trajectories make the most sense to the product, the things that it needs to do frequently, a sort of edit to a file, a research approach, different activities it needs to do, and then it rewards those things the more it does it, reinforce them. So the best things float to the top, the worst things float to the bottom, and they're ignored. So I'm applying sort of the idea of kind of neurosynaptic network to a latent vector space. I can go deeper down rabbit hole want, but
This is kind of a rag that's.
it's an augmented system, exactly what it is. So some people retrieval augmented generation. The difference is I'm not doing this is pre-retrieval. So what I'm doing is I'm taking this information before it ever asks plot, it asks my system. Have we done this before? What's the best way to do that? And it's the answer, yeah, we've done this like 50 times. It doesn't even bother to go to plot because it already put the answer. that saves you money, it's cheap, I don't want to spend more than I have to, but it also is effectively training the system, and I do that super fast. Now, the key is this space that sits around anything below 100 milliseconds. Now, 100 milliseconds is the magic time it takes you that you don't see. When you blink, that's roughly 100 milliseconds. The reason you don't see it is your brain doesn't interpret anything under about 100 milliseconds. So what I'm trying to do is I'm trying to make these things happen faster than you can perceive. And in the case of the system, I was able to build it in a Rust-based framework, and essentially that happens in microseconds. In the case of microseconds, that means when you make the request, it's thinking, doing all these things, we can remember that it's done this before, and that's happening so fast that you can't even perceive it in your brain, like 1,000 times faster than a blink. And you do that in parallel, many times. So, and then once it gets the answer to the problem, and then passes that back to the LLM and says, here's the answer, and gives you the sort of guidance to move to the next step. But it's happening so quickly, it doesn't make it slow. All the art is not. Yeah. It's tiny.
Zero over time is this definition represents something.
No, it's what I've got is what we call temporal compression. So the temporal compression allows short-term memories to be uncompressed. So what I did recently, an hour or two, is basically fully available, just what I did. What I did several hours ago yesterday is compressed more. Think of when you go to bed at night, and everything that I'm telling you right now is all fresh, it's all in your mind. You get up in the morning tomorrow, I don't remember what else I'm talking about some crazy shit, whatever, and that's going to give you sort of the general idea. And you might go quote me on some of the things I said, and some of those things that I said might stick with you for a while, but over time, those memories fade, they're being compressed. So I'm doing the same thing. Over time, the things I did a month ago or a year ago are much more compressed, and I'm compressing those into a state that allows me to recreate those memories through a trajectory, or seed, if you will. That seed allows me to go and gain that information again and recreate it in a deterministic path or pattern. So if there was a series of things that I had to do to get the problem solved, I can recreate that pattern at any given point by recreating the trajectory. So it allows me to reverse engineer the path that took me to learn that thing. But it compresses all that information into 1, 3, 5, or 7-bit integers. I will go to that. But the more the story is works really well alongside the animals.
Can you share one more thing? How do you secure the attack?
Yeah, so I've got a series system. Remember when I said I can, and that's what do I call that? AI defense, I call it. The AI defense system essentially allows it's I can find where that is. It's in B3. So you see different packages in the bot flow folder. I get AI defense. So the AI defense system essentially, remember, I worked in those really tiny spaces of time. If you're ever class the ability to do things into those microsecond or sub-millisecond time frames, you're able to sort of have a kind of a detection of different patterns that might potentially be exploiting the system itself. So in this case, it detects things like prompt injections. Are you trying to manipulate me in a certain way? Is it trying to jailbreak me? Is there credit card information going into the information? Is it secretly trying to siphon my information in some other system? All is happening really, really fast. That's also happening at the same time that it's actually learning. So all these features in the system are operating in real time, or what they call sublinear time. Time that's below sort of the perception of human. Yeah, so it's doing quite a bit of stuff here. This is the guidance system for how the AI defense system works. But each one of these relates to another. We go to GitHub, and these are all projects that underpin the system itself. So this is the core database system that I'm using that I built my tech stack. So this is kind of the productized version of the data structure, and it allows you. I give a little inspiration here. Self-learning. The agent, it saves it to a sort of binary file. It does. It's crazy technical, but it creates a graph structure, a super fast one. It gets the results. It learns, adjusts, adapts, and then it retrains itself to find the optimal path and solutions to the problem. point plot at it and say, build me something. Yeah, good question.
Yes, a little while ago, I was thinking, but some process ran into for
Supply chain.
it's something like your air defense, or like all something. I think scan, before you start investing or downloading skills, things like that. Is there something that goes, that's that?
And that's what I'm trying to do. So the side effect of being, one guy and really popular online is everyone's trying to exploit the system. Right? And I'm constantly people are trying to map me in. This one random project I brought up in the stat, I'm down 148,000 downloads this week. And that's just one of like dozens of projects, thousands of projects I have that are probably in the same ballpark. So when I get a week, I'm doing a couple million downloads. So what everyone wants to do is they want to get their bullshit crypto, whatever, into my system and then have it sort of guide and steal whatever for that purpose. So I'm always on the watch for someone, people trying to exploit me. So I have to use this to manage all these different repos. That's how I'm doing it. But it doesn't, and what I also know, I don't automate the sort of acceptance of like issues or PRs, things like that. That's the primary mechanism that we're trying to exploit. But there's also secondary packages and things that they might discover while doing that role that I was showing you earlier. Because I'm giving it the ability to kind of just go and do its thing. While it's going to do its thing, I don't want to then find its way to a spot where it might be taken advantage of, which in the log, code, and other codec type projects, it can do very easily because it doesn't know what's right and what's wrong particularly well. The AI stops that sort of unknown exploitation. You see it coming to that. Like that, like on a daily basis. So, yeah, it's weird world we're living right now. What's that?
Any successful?
Yes, of course. I'm not in Mr. Invincible. The most recent hack was it was a speed hack. I like 4 years ago, I created some marketing tool on plot or Cloudflare, and it was, I don't know what I was supposed to do, so I don't remember, but basically I accidentally included one of my keys in that particular repo. And at the time was secure, but like everything you forget about it, time goes on. And what was secure was not secure. And they were able to gain access to my Cloudflare key, which basically meant they could create other little workers under my domains. Those workers, like these are those web apps that do certain things. And so they used it to create a bunch of sites that sold big access. I'm like, but I think what they're really bragging about is back to red lights like me. But again, my AI told me. Yeah. There's 2 days, unfortunately. But it wasn't like a major hack. It was like more of those hacks you're embarrassed. Like, I'm supposed to be like Mr. Whatever, but yeah. No one's perfect. Now, if I can get hacked, I'm pretty sure you're the one. And there's certain operators that are just going to access. You have to basically just know that the Americans, probably the Russians, and the others can see your stuff. But I don't know.
So that's the point that I guess, everything you're building is using code. Then as you're using code, training it, then learning how to do it.
No, I separated. Right? Yeah, I'm just a comparative bastard. I separate that all into separate that quad receipts. I post to the RBI to see how I do it, but in essence, what the system does is it operates independently of Plot. So a lot of the signals and requests never go to Plot or OEX or whatever provider I'm using. And the other thing I'm doing is I'm training local models. So my other package I have here is just pretty popular. I don't remember what it is. It's through Vector, the LLM. Yeah, this one essentially allows me to create a local model that runs on CPU. No CPU required. Now, it's not a model that you use for like everything. It's not going to be fun, but it's good for things it needs to be good at. Like if I need a specific model to understand finance or pharma or some random project I'm doing, it's going to be good at that. But if you ask who the king of France was, it's not, no. But that's what narrow is really good for things. Like if you get a bunch of really narrow and smart models that go one particular domain really well, I don't need a giant model. I just need a really smart brain that I can train to do that one thing. It knows everything we just know about one dentist practice, but it doesn't know anything about the dentist down the road. Yeah.
I just looked at the agenda and noticed that both Brad and Nick were gonna give it.
Okay. We're doing some other demos too. How we do? We're 8.
It's 8, yeah.
Nick's been creating some pretty cool demos and things. You want to show off some of your stuff? You want to make some demos and refresh this with it? It's down here.
Question we have.
Yeah.
So, what are your thoughts on how we see in regards to all the morning without the pumps and security, putting their more than
It's hard to tell. I only got it and I'm not even done buying it. You know, there's a lot of hype in this industry. I haven't seen a huge improvement in development over the last few months. Good. I would like to see it over here. Oh, nice. And we tell them, yeah, improvement skates for like, 8 hours. Easily, right? You just wind up and so we went to Budapest last week, and I hadn't actually been that far in Europe, so it was really nice. And we went to a craft conference and we did some training, and Robert and Aaron did some training too. So we had an Agentics Foundation meetup in Budapest. So you feel around my computer, Martin? Go and take it off my what's up? Sorry. This is not.
There's the Arsenal permission bigger for forgiveness.
Yeah, like private stuff. But my business sketches on. But yes, we go to the Budapest channels that stuff like this event in June and get a chance to I suppose. When we go to these new places, I find mine some problems. One of which is I like to go to different repositories, like all of the repositories, to get the file and how extension up, right? And when I say, okay, what crazy thing can I build like combining this existing projects? So then you want to go like kind of just like piggybacking my front group, right? So it's really, really cool to do that. But then I like to do things that good for the environment, good for humanity, and right? So in these other places that go, Vermont was the place we went for a retreat earlier on in the year, and I created something for nature because Vermont's all about nature. But this is Budapest, right? And I'm like, well, what's going on in Budapest? What can we do to help people in Budapest to find a get there using their industry books? I always say 100 years in the future, with technology available today, and so on and so forth, Rust and TypeScript that's necessary. So they we also made attention on the ride. One of the Agentics members in Budapest drove us from the airport and used Agentics at the city, which is really cool experience to get started. And he said, there's like hundreds of prospects in Budapest, and only a few of them are spots. So the club was really struggling to find something that could be good for the people in Budapest. I'm like, what about these spots breaks? Like, can you use them in some way? They're more energy. That's a great idea. Like I got the AI to pick that up, but I need to get real human rules of help, right? So what this is designed to do is use the cognitive seeds and appliance devices and monitor these hot springs for a couple of different reasons. So one of which is the existing ones that are already using this for their energy, heat, etc. If there's too much heat going in the building, there aren't open windows, well, there's wasted, right? So you can revert it to another building next door, adjacent, across, whatever, and designed to actually just notify building owners or keeps itself. So, but then the other part of this has to do with hot springs are not being used, right? So how much money would it take to actually harvest this energy, right? then how much would you save on your energy bill? And then how much I'm gonna take, right? And then second, the carbon emissions. I'm not seeing, yeah, so you're seeing energy savings and carbon reduction there, right? So, you know, I really like the sustainability going. We used to teach this course in Rob how sustainability making the business case, right? That eventually became an idea, yes, of our friend, right? But, you know, so I had a really strong connection associated with that. And this was like this is a cool project, you know, and then Bruce's son actually helped me do this map. It didn't look this good before he got involved in, you know, when he gets excited about something, he's kind of like this old man that starts to really dig into it, right? So we've got a couple of different views here, but you can see, there's a whole lot of these, right? And let's see if this is gonna behave for me. Okay, so it's giving you a little bit of information. And there's the 3D, and let's see if that will. So it's not like super quick, but you can see there's a couple of different views. I had one like kind of crappy map, and it's like we can do better than this. You know? Things like 15, 16 kind of thing. It's like we can do way better. I'm like, let's work on this. And you know, we found some maps and helped me out with this last piece. But so that's that project. And to give you an idea, like I wrote this and Waldo was actually watching and training with people. So I was doing other things. So this was like kind of a fun thing. And I wrote it out with 1,000 errors and fixed them. So, but you know, it's 20 minutes, 92 hours, and this is the product. You know, it's unreal.
Have you tried to improve the performance by using Gaussian flats instead for the map rendering?
Something for me to look at, right? So what I basically used was I was like, okay, well, I'll give you something that's little views as a replacement for that has that kind of level to down. That's how I did it. And don't ask me to use, man. Like I don't, but yeah, like definitely check that out because a lot of these applications I'm building involve some way, right? So you guys know look at that. Moving on to a couple of the vlogs. So this is a really cool one that people seem to like. It's a forklift, danger, monitoring system. So you can see the little forklifts on them. So they have like seats on them with so there's a recording video. And you can see them driving around.
Was this hypothetical or you built them? Was this hypothetical or you actually built this in real life?
So this could work in real life if someone actually had a warehouse with forklifts and had this seasoning appliances. So it's a real thing. This what you're seeing is simulation, but it absolutely is functional. So the forklift one people seem to like, respiratory distress. Okay, maybe I should slow this down a little bit. But again, Ruben has in the last few days been really making these for real for them. So
So the respiratory distress work, is that part of that demo with the forklifts, or is that a separate?
this is a separate one. So these products have different cases, and I'm not gonna take a ton of time, but I never thought I'd get this excited about livestock, but this livestock one, I really think is cool. And it's just like, and at first it didn't do like a very good job. And this is what I probably have to do for that rest of GC. So like, you can see the cattle, right, being monitored, and then the environment. So the animal count. But I do like these, the barns, you can see the different barns.
I think when you say monitors, like these are like the seat is this little chip device. Then there's little sensors that are on it, not cameras or stethoscopes. They're actually.
Yeah, it's using Wi-Fi, right? And Ruben will go a little bit deeper into this, but this is
David has some examples.
yeah. Yeah, so that connects to other sensors. So you know all the stuff I was showing you about this kind of like vector learning structure that I did for the agents. Turns out you can apply that to just about any data and sensors that exist in the world around you, and it can understand things in different ways. So what we're doing is learning about the information that's in proximity to it. So if you connect it to a heart monitor, it's going to learn what your optimal pattern for your heart is. Or if you connect it to a business system, it's going to learn what your business and how your business system needs to be optimized for performance for that. So it's just capable of learning alongside of whatever information you feed it. And I know it sounds a little crazy because it is, but as it works alongside over time, it gets smarter incrementally. Where traditional AI, it was pre-trained, it's like, here's the entire internet, now answer everything and nothing in particular. This is the opposite. This is I'm smart like a bird that knows how to fly south, but I'm gonna learn everything else. I'm gonna learn that when I go near an animal, it might try to eat me. That kind of thing.
It's very right? And with the stuff of things, like it really is, and it's just like we're all just going around Ruben and his creations, and this is where it's leading. So I really like this part, like it just shows the actual like fence, and if someone like one of the cattle produces the fence, the farmer knows, so that's a real problem. Fence is staying out, and things like that. But I am from the country, so I'm a little bit honest about I think it's strong there. And it's, you know, there was a cat, there was one chicken. So this one's a happiness score. No, I'm not gonna go into the version state that one. Maybe he'll talk about it after, but so okay, so there's all kinds of cogs. I'll get out in front of this for a minute, but there's about 109 plus cogs, okay? I'm sure you guys are about 60. And when I first met Ruben and he started like naming some of his stuff after like people he knows, right? I'd go to bed and I'd be like, one day I'm just gonna actually name something. Because I look at them just from the longer, and then it never really happened, right? And I'm like, I chance, I'm like, why times you come, you know, it's gonna be something really special. And then we got using these clocks, right? Build these clocks, and then Ruben built this thing called the house. Okay, so the measure show level of the house. Okay. And then he kind of was bugging me about it, and then there's an algorithm inside of it. So and then he's like, why don't you look in the browser cog in the algorithm? I named it after. and you know, now I'm just announcing it in public to people because he's going to anyways.
The arousal cog is definitely a useful cog. It mentions how excited you are about things. You know, think about the retail applications. Yeah,
there's a cog for everybody, right? So this one here is a little bit more tied into the discussion that we're having today. Swarms and agents, things like that. Like it's the like we have there's a concept that we've created called a hive mind. So that's this guy over here and it's a storm around and a few moving from my mind. And this is like enterprise scale, and most people would just have one going, you know, maybe two, none. This many, but yeah. So I was really happy with this one. It took a long time to get into it back there, but it is cool.
And what's crazy is if you point the right sensor at a bee's nest, like a 60 gigahertz radar, which you can buy for like $20 on AliExpress, you can start getting these signals, and you can tell if the beehive is healthy, what they're up to. Is the queen actually, you know, producing enough offspring, all kinds of stuff. And that's all done remotely by pointing some, you know, radio frequencies at a bee colony.
And are the cogs like open source?
They're all open. Yeah, so we've got an open model. I give away, except for some hardware and some enterprise things, we give away most of it. Mm-hmm. And, you know, the idea is to create an ecosystem of people building this kind of world of AI, the AI that exists for the sort of real world. And for me, in a world where anyone can build anything by asking the right questions online, the next frontier, if you will, is everything that isn't online. Just to clear, so is a cog like a defined use case that you go up? Okay. It's a little app. It's delivered. Usually it's a Rust-based app that gets delivered to the device and then can start learning and adapting based on the parameters of that particular application. An arousal brags, you know, look at the heartbeat when someone enters the room, and some other indicators that the person's excited. A bees, they'll look at other signatures.
It's one sensor per cog, essentially.
Yeah, the cog is pretty lightweight little machine. We're gonna come up with some other sensors and other devices. We're just getting going. The company's only formed, about 2 months ago.
But it would be one cog per sensor, so if you wanna do multiple.
Depends on the sensor. If you're using wireless sensors, it can be many.
Too many?
So yeah,
Actually,
or working in unison, but usually I think we limit to 3 per seat.
So is there, yeah, if you're experimenting with a seed, how quickly can you hop across like use cases?
So you're pouring Claude at and say, Claude, build me some crazy stuff like when Nick did.
And then it creates a separate memory, like I'm just trying to.
Yeah, so the optimal approach would be to sort of download my root flow or whatever your favorite harness is, if it's not mine. And then point Claude or Codex at the device and have some sensors. There's different sensors for different things. Like, for example, let's say you want to detect water leakage in a pipe, then you might get a vibration sensor that can pick up that minuscule vibration change, which would be like sub frequencies kind of thing. Depends what you're trying to detect.
Could you detect like nitrogen levels and pH levels in soil or
Yeah.
things like that? So
I can do real-time DNA analysis. I can detect when you take a scoop out of the water, and then put it through a gene analysis system. I can separate the different DNA parameters within that in almost real time. So, like for example, let's say you want to say it's a bad example, who's doing certain kinds of drugs. Literally, you can detect that. What's the prevalence of dementia? But it's anonymous because you're just getting sewage. But yeah, then it separates the parts and learns the structure of those parts and says, well, this is different than that. But this is all the same. Don't pay attention to what's the same. Only look at what's different. When you start looking at what's different, it means that you don't need to look at everything to see something. So it's basically this kind of weird inverse pattern.
What sensor data would you use?
Any sensors you can get, like go on to I love AliExpress for that kind of Alibaba. Find random sensors and they're all cheap. And now that the Americans banned them, you can get them in like a week. It's the best thing ever for getting stuff from China. Oh, by the way, guys, we're almost out of time, and I think we're gonna have a hard stop, and we want to have some networking. Nick, amazing. Yeah, we can't linger here, unfortunately. Yeah, on our website and my yeah, give them all away. I know. So the physics you do. Yeah, so. Yeah. Then stand the bottom is to see somebody starts to like then you